Okay, so the first problem is x minus 2 squared plus 2y squared equals 4. So what we're doing is we're taking the derivative of each term with respect to x. So we have the derivative with respect to x of x minus 2 squared plus derivative with respect to x of y squared is equal to the derivative with respect to x of 4. So the first one we could multiply out using the chain, using FOIL, but let's use the chain rule. So the chain rule, what we do is we'd say f of u equals u squared and u of x equals x minus 2. So f prime of u equals 2u and u prime of x equals 1, because the derivative of negative 2 is 0, derivative of x is 1. So f prime of x is going to be 2u times 1, which is going to be 2 times x minus 2. Okay, so that's the derivative of this part. So we get quantity 2x minus 2 to the first power. Okay, then we take the derivative of y squared. Well, the derivative of y squared with respect to y is 2y. And then because we're using implicit differentiation on this one, because this is y, we're taking the derivative with respect to x, we need y prime. You remember y prime is also the same as dy dx. Okay, and then the derivative of 4 is 0. Okay, so now you would move the terms involving y prime to the left-hand side, move the other ones to the right-hand side, divide by, you don't have to factor out y prime because there's only one term. So you get negative 2 times x minus 2 divided by 2y. And you can see that I can cancel out the 2's because that becomes 1. So you get negative x minus 2 over y. Okay, the next one. So I have y to the 5th minus x sine y minus 3y squared equals, plus 1 equals 0. Okay, so we're going to again take the derivative of each term with respect to x. And I'm going to go ahead and actually do that derivative because you get 0. And the derivative of 0 is 0. Okay, so let's look through each one of these. So this one is kind of like we just did previously. You'd use the power rule to take the derivative of y to the 5th. But because I'm taking the derivative of y with respect to x, we have to put a y prime there. Now the next one is the product rule. So if you want to use, if you wanted to say h of x, and actually it's h of x and y in this case, is going to be x sine y. We could say, h of u. No, this is, I'm thinking of the chain rule, sorry. So we're going to say f of x equals x, and g of y equals the sine of y. So when you take the derivative here, we're taking the derivative with respect to x, so that's just going to give you 1. Whereas if we take the derivative here with respect to x, we're going to end up with the derivative of the sine, which is the cosine, and you're going to multiply it by y prime. So it says the derivative of a product, this function that's a product of two parts, is going to be f of x times g prime of x plus f prime of x times g of x first times the derivative of the second, derivative of the first times the second, or you could say derivative of the first times the second plus the derivative of the second times the first. Same deal. So you've got f times g prime. So you'll have x cosine y, y prime. I'm going to put that in parentheses. And then you have f prime, which is 1, times g of x, which is sine of y, g of y. Okay, so that we can substitute that in there. So I'm going to put the minus sign out in front, and then we'd have x cosine y times y prime plus 1 times sine y, which is sine y. The next one, you're going to have negative 3, and the derivative of y squared is 2y, but because this is y and that's x, you get a y prime, and that's equal to 0. So we can see that we have how many terms that involve y prime. We've got that one, that one, that one. So those three need to stay on the left-hand side. And this other one needs to go to the other side, this negative sine y, so that when it goes to the other side, it'll become positive. If you factor out the y prime, so you get 5y squared minus x cosine y minus 6y, and that's equal to the sine of y. And then you divide both sides by this term, so you get the sine of y divided by 5y to the fourth minus x cosine y minus 6y. And you don't need to simplify it. Of course, to evaluate this derivative, you need to know both the x and y solutions. Okay, next one. So you've got x over y plus y over x equals 2. So here we have the quotient rule, and the quotient rule says that the derivative with respect to x, in this case f of, well, for the first case, you've got f of x over f of y, g of y, where f of x equals x and g of y equals y. And the quotient rule says you take, of course I forgot it. I know it's ridiculous. So I just do that to make you understand why I let you have a cheat sheet, because I can't remember after 10 years. Okay, so the first one, you get, it says g of x, but in this case it's g of y, times f prime of x minus, then you'd have f of x. So when you take the derivative here with respect to x, you'll get 1. And when you take the derivative with respect to y here, you'll get 1 times y prime, which is just y prime. Now, in the second case, the numerator is a function of y, so you get y, and the denominator is a function of x, so you get x. So when we take f prime of y, we'll get 1 times y prime, and g prime of x equals 1. So from that, we can say that the derivative with respect to x of x over y, using the first thing, is going to be g of y times f prime of x minus f of x times g prime of y, all divided by g squared, g of, in this case, g of y squared. So that'll be over y squared. And the second case, the derivative with respect to x of y over x. So that's the second one. So it's going to be, in this case, it's g of x times f prime y. So we're going to start with the g part. So it'll be x times y prime minus f of x, f of y, okay, so y times 1 over x squared. So you see what happens is these switch order, and the denominator is y squared and it's x squared. So now if I take the derivative of each one of these terms, I've got the first two. So you're going to have y minus x y prime divided by y squared. So that's the first one. And then you've got the second one, which is plus x y prime minus y divided by x squared. And that's equal to 0. So we need to, let's move the second term to the right-hand side. This is so I can just cross multiply. So I'll have a negative the quantity x y prime minus y divided by x squared. So I take this term, move it to the other side. It becomes negative. Okay, so now if we cross multiply, we'll have x squared. This term's that. Y minus x y prime. And then we'll have minus y squared times x y prime minus y. Then we'll multiply them out. So you get x squared y minus x cubed y prime is equal to negative x y squared y prime, x y squared y prime, and minus, plus, because I got minus times a minus, so it's plus y cubed. Okay, so let's move the y prime stuff to this side, so this will become positive. So you get x y squared y prime minus x cubed y prime, and then we'll move this term to the right hand side, so you get y cubed minus x squared y minus, sorry, let's try this again. Okay, so this goes to the other side, so it becomes minus x squared y. Then you factor out the y prime, so you get xy squared minus x cubed. The right hand side remains the same, and then you divide by that term, so you get y prime is equal to y cubed minus x squared y divided by xy squared minus x cubed. And it kind of makes sense here because you've got y cubed, you've got x cubed, you've got xy squared, you've got x squared y, and so that looks pretty decent. Okay, and the final one is finding the equation for the tangent line. So you've got the function, the implicit relationship, which is xy plus y squared equals 6. So you take the derivative with respect to x of this product plus the derivative with respect to x of that term, and that's equal to the derivative with respect to x of 6. So here we're going to use the product rule. So you have the first term times the derivative of the second, which is going to be derivative of y is 1. Because it's with respect y with respect to x, you get y prime. The second part of the product rule says it's the second term times the derivative of the first. So the second term is y, and when you take the derivative of x with respect to x, you get 1. The next one is 2y y prime, and that equals 0. So we're going to put the terms with y prime on the left-hand side. Move the other thing to the other side, which is that one. Factor out y prime and divide both sides by the term in the parentheses. Okay, so that's the derivative, which is the slope of the tangent line. So we can say m is equal to negative y over x plus 2y. And our point is 1, 2. If you go back here, you'll see that if I stick 1 in for x and 2 in for y, I'll get 1 times 2, which is 2, plus y squared, 2 squared, 2 plus 2, 2 plus 4 is 6. So that works. That is one solution. Okay, next, we're going to evaluate the slope add those values. So you get negative 2 divided by 1 plus 2 times 2, which is negative 2/5. So that's my slope. I have the point right there. So you take y minus y1 is equal to mx minus x1. You know, this is x1, y1, that's your slope. So you get y minus 2 is equal to negative 2/5 times x minus x1, which is 1. So you multiply out the negative 2/5, so you get positive 2/5. Negative times a negative is a positive. 2/5 times 1 is 2/5. Okay, then you add 2, or you can move the negative 2 to the other side, make it positive. And then you can rewrite 2 in terms of fifths. So you get 2/5 plus 10/5. And then you can combine the last term. So it's 2/5, negative 2/5 x plus 12/5. Okay. So that's the equation for the tangent line. So let's prove that's correct. What we're going to do is we're going to plot this function, which I have plotted before and it does work. So we go to the equation, implicit, and the function is xy plus y squared. Xy plus y squared equals 6. And here we have 1. The y value is 2, so we should have the function go through this point, which we do. Okay, so you can see x equals 1, y equals 2. There's also a solution down here. So there's 2 solutions for x equals 1. That's why it's not a function. Okay, now we're going to add another equation, which is going to be the equation for a line. And that's, that's something beyond the scope of the problem. So we're going to close that. So we're going to add a line by doing explicit version. So you get f of x, which is y. So you get negative 2/5 times x plus 12/5. And we'll go from x equals negative 5 to x equals positive 5. And we do that, and you can see right there that the slope of the tangent line works out. It's just tangent to the curve. Okay, so that's it.